Hello everybody, Doug here. Welcome to the final part of this three-part series in which I'm building a replica of Brian May's legendary Deacy Amplifier. The first video was an introduction to the Deacy Amp and this project. The second covered the components in the KAT circuit board kit and assembling these into a functional amplifier. This video is about designing and making the loudspeaker cabinet, and I'll finish with a final assembly of all the component parts. So let's begin by talking about the physical form of the loudspeaker cabinet. The cabinet measures approximately 12.5 inches wide by 6 inches deep by 8 inches high. It's constructed from 1/2 inch thick chipboard sheet finished with a hardwood species marquetry veneer such as sapele. The box joints are standard 45-degree mitres reinforced with splines which are 3 to 4 millimeters, that's 1/8 to 5/32 inches thick, and 7/16 inch or 11 millimeters wide, running for most of the depth. The splines on the KAT Deacy are made from plywood, but I'll use what I have to hand, which is this selection of oak beading strips. Now let's take a look at the front baffle and rear cover, which are also made of a 1/2 inch thick chipboard sheet. The pieces I'm showing you here were not made by me. I'm going to cut everything to my own design, which I'll show you shortly, to make sure I get a consistent fit. Knight Audio Technologies have offered a cabinet in kit form, which just requires final assembly and veneering, but this wasn't available when I started the project in winter 2022-23. The lack of availability of either an original vintage loudspeaker cabinet or a convenient kit presents me with an opportunity to make a more detailed video, so let's embrace this. The front baffle and rear cover are held in place by wood screws into 1/2 inch square softwood battens, so I'll use some pieces of scrap white softwood timber such as this, which is 15 millimeters thick, and I'll size that up using the CNC machine. Let's begin by looking at the design of the loudspeaker cabinet and plan out the CNC cutting using a CAD software utility. Nigel Knight has kindly sent me his design survey of Brian's original Deacy amplifier in Adobe PDF format, and I've taken some basic measurements from my own KAT Deacy amp replica. I used this information to work up 3D objects in TurboCAD, from which I can then export files in a suitable format for the next stage of the process. I then use MeshCam to generate CNC machine toolpaths in G-code, which is basically a long list of rectangular coordinates with some additional information to tell the machine what speed to operate in each direction. A popular software utility for these tasks is Autodesk Fusion 360 because it's free for hobbyists, non-commercial use, and for qualifying startup businesses. The loudspeaker cabinet which John Deacon used was a typical 1960s bookshelf-sized unit from a domestic hi-fi system, although similar designs were deployed in public address systems, in offices, and small industrial premises. I don't have any specialist woodworking equipment, or even a workshop bench. I've only got a large table saw, good quality wood chisels, and a handheld laminate trimmer router. So this situation forces me to make the most of what a hobby-class CNC machine can achieve. Cutting out the panels, which I'm showing you here, and chamfering the mitres should be straightforward, but routing the spline rebates will require some ingenuity. As I manipulate some of the 3D objects in TurboCAD here, you can see the left and right panels with their spline rebates and mitres, the upper and lower panels with their spline rebates and mitres, the front baffle and the rear cover, and all of the softwood battens, some of which have cutouts. And you can also see how everything fits together. Big shared retail park DIY stores, in the UK at least, no longer seem to stock chipboard of the type used in cabinet making. Plywood is still readily available in various thicknesses, but the only other engineered timber products available off the shelf are those commonly used in construction, such as Oriented Strand Board, or OSB, and Multi-Density Fiberboard, MDF. The acoustic signature of the Deacy amp is unique, and a combination of various factors which necessarily includes the resonant quality of the housing. This will be a function of the density and physical size and shape, so for this reason I recommend that you use original materials if you're making your own Deacy cabinet. I bought this 4 foot by 2 foot 1220 by 610mm sheet, mail order. I'll need to cut it into 2 pieces so it will physically fit on the bed of my CNC machine anyway, but this means I'll have enough sheet to do some recuts if any get damaged during the cutting process. So I've already planned out how I'm going to execute these cuts using TurboCAD. So I've just laid down the large rectangle there, which is a 1220 by 610 for the large sheet, which I'm going to cut in two. So I can fit 600 to 610 millimeters on the machine bed, but I'd like to have a little bit of width spare there, so I'm going to stick with about 550 millimeters. That should give me enough room to lay out all the 6 sections, with enough space around each section so that the cutter can move freely around. Here I'm using the Makita laminate trimmer router with a guide fence to cut the chipboard panels in half. Let's take a look at some of these sequences from the various CNC cuts now. First up, I'm preparing some of the softwood battens by cutting them into strips and squaring the profiles to a 1/2 inch by a 1/2 inch. This offcut of oak board I used in my Red Special build is precisely thicknessed to 3/4 inch or 19mm, so it makes for a good spoil board. And here I'm showing you some heavily edited highlights of the chipboard CNC cutting sequences. Okay, let's examine the cut chipboard panels now. Other than some dressing of the mitered edges with 120 grit abrasive paper to remove filaments, these pieces are straight off the CNC machine. Now I've never routed chipboard either manually or via CNC, so I had no idea whether the cut edges would be clean or whether the chipboard substrate would remain intact or break up. Anyway, as you can see, the result is highly satisfactory as far as I'm concerned, although I did find that the amorphous nature of the chipboard substrate resulted in clean cuts in certain orientations, but quite untidy cuts in others. I generally use double-sided adhesive tape for holding down the MDF spoil board and my workpieces. One disadvantage of this method is that cutting edges of the cutter can chew up the tape and clog the cutter on the final pass, and this can impair the cut profile. To manage this, I stop the machine and clean the cutter as the cutter moves between the final pass on one completed panel and the first pass of the next panel. I've taken the opportunity to use the CNC machine to drill 1/4 inch diameter pilot holes in the front baffle to accept stainless steel M4 threaded inserts for the loudspeaker mounts. I'll also use these to mount the amplifier circuit board onto the right-hand side panel. If you have bought a self-assembly Deacy cabinet kit, or you're making your own for the first time as I am, you might be interested in what types of corner clamps are available and which are best suited to this application. I progressed this build in stages and didn't really consider up front how I was going to glue up, assemble and clamp the panels by myself. I sought advice from somebody more experienced in hobby cabinet making, and I was recommended to use band clamps. Taking into account that I already have several of these Irwin quick release clamps, for which corner clamping attachments are now available, the small size of the cabinet, and the need for some internal angle support to guarantee precise alignment, well, I chose these items that I'm showing you here. After evaluation, I decided not to use these Wolfcraft mini clamps because the clamping force is not sufficient for this application unless the spring is under quite a lot of compression, which seems to require the jaws at least 3/4 inch open. To achieve that, I'd have to pack the jaws with spacers, which is more work and not really a quality solution. Before moving on, I did a dry fit test to check the alignment of the mitered faces and to determine how effective the quick release corner clamps would be. As you can see, the alignment appears to be satisfactory with no remedial work required at this stage, and the quick release clamps are straightforward to deploy. I mentioned earlier that the original Deacy cabinet has splines at the mitered joints for alignment and reinforcement, and that some ingenuity would be required to route these precisely. It's likely that the structural integrity of a small, non-load-bearing item such as this would be satisfactory without them, but I wanted to replicate this feature for both authenticity and because I thought that they might help a novice cabinet maker achieve a better result. I considered a number of methods to route the spline rebates, including leaning them off the end of my CNC machine, but I couldn't achieve enough vertical clearance this way, and achieving precise alignment in both X and Y directions would have been challenging. Ultimately, given the precision required and the fragility of the chipboard, I couldn't really justify not making the bespoke alignment jig that I'm demonstrating in this sequence. The trapezoidal-shaped jig is made from nominally 1/2 inch, actually 11mm thick plywood. The panels are CNC cut and are rebated into the sides. I glued the panels together using EvoStick non-drip contact adhesive, and the design allows each chipboard panel to be held at a 45-degree angle between a fixed fence and a movable fence, which I've CNC cut from offcuts of oak block. This orients the mitre level with the top plate. The 2-flute 1/8" diameter cutter stick-out is set using calipers to route a 5.5mm deep rebate, and the adjustable metal fence is set to position the cutter laterally as required. Let's move on to veneering the panels. I don't intend to demonstrate any of the veneering process in this video because I covered that in part 2 of the 4-part series on finishing a Brian May Red Special body. I bought plenty of Sapele marquetry veneer to allow for test cuts and inevitable wastage. I cut these to size with a surgical scalpel blade, leaving 5 to 10mm overlap for trimming on the outer faces, but left a small gap to the edge of the inner faces to remove any risk of poor fit on the front and rear cover rebates or the edge mitres. I glued the outer face veneers with tight bond aliphatic wood glue and weighed them down with heavy items placed on top of an MDF board and a silicone mat. This method worked well on the mahogany veneers for the Brian May Red Special body, but here it's resulted in an unexpectedly large amount of glue bleeding through the particular regions of the veneer grain. So for this reason I used EvoStick non-drip contact adhesive on the inner surface veneers. That worked well too, so please bear this in mind when selecting an adhesive for your build. In the finished panels here, I have removed as much of the dried glue as possible by scraping with a brand new utility blade and flatting back with 320 grit abrasive paper. However, before proceeding with staining and varnishing, I prepared a test piece to assess whether remaining dried glue would impair the finish. The result of that test was satisfactory, so I moved on. Rustins wood dye for interior and exterior use worked well on my Red Special build, so I'm using it again here with a recommendation to apply the light teak colour. The Sapele veneer is a darker brown colour than I was expecting, even after abrading, and I considered not applying any wood dye at all. However, given that I'd already bought it, and with the experience from the Red Special build that applying stain directly to the wood veneer accentuates the grain pattern, I decided to go ahead. The product instructions recommend that the stain is applied to the wood with a clean dry cloth, and 1 coating should be sufficient. I'll just speed up the rest of the sequence here to finish off this segment. You can see that some patches of dried glue remain even after scraping with the utility blade and sanding with 320 grit abrasive paper. However, this doesn't seem to prevent the wood stain from penetrating the wood surface. Okay then, let's move on to clear coating the stained veneer. The KAT Deacy cabinet has almost no discernible sheen to the veneer, and I personally have never seen a shiny wood-finished loudspeaker cabinet, but I don't think it's sensible to leave veneer stained but uncoated. While I was considering how to finish the veneer and thinking about applying a hard wax oil, I got a recommendation to use this Rustins quick dry varnish in clear matte. As you'll see in the next sequence, the formulation is ideal. It's easy to apply evenly but sparingly, it's touch dry in 20 to 30 minutes, and can be recoated in 2 hours. It's also water-based, so you can clean your brush in water. The instructions suggest applying with a good quality synthetic fibre brush, so I'll use this same 1.5 inch wide watercolour brush that I used to apply the Rustins plastic coating to my Red Special guitar body. The liquid is opaque and milky white, which is unusual for a clear varnish, but the product instructions caution that if the liquid is clear, then you haven't agitated it sufficiently before use. To ensure that all 4 panels could be easily positioned accurately for gluing up, I decided to get myself some helping hands by making 4 alignment blocks. I had plenty of plain square mahogany offcuts after sizing Red Special guitar neck blanks, so I used the CNC machine to route 1 inch deep square section rebates down the centre of 4 of them. I measured the thickness of the veneered panels using calipers, and they were reasonably uniform at 13.6mm, plus or minus between 0.1 and 0.15mm. I machined the rebates slightly wider at 13.75mm to allow some space for packing with plastic shim material. The final job I did before gluing up was to fit the stainless steel threaded inserts for mounting the circuit board into the right side panel and fill any gaps between the chipboard and veneer with wood filler on any vulnerable edges. After making the panel alignment blocks, I did another dry fit check, this time inserting the splines. I was aiming for a loose interference fit after gluing up and applying full clamping force, so I made some final adjustments to the edges and faces of the splines with 120 grit abrasive paper. To check the fit tolerance across the mitered faces, overall squareness, and what quality of alignment the blocks would offer, I placed the rear panel in its rebate. That result appears to be satisfactory and matches what I had designed. At this stage, I also fitted stainless steel threaded inserts to the inner face of the front baffle. I pre-drilled 1/4 inch diameter, 3/8 inch deep pilot holes with the CNC machine, then manually drilled 5/16 inch shallow countersinks around the top to alleviate the tendency of the chipboard to break up. After reviewing the clamping arrangements, I decided that a combination of a band clamp and the 4 quick-release corner clamps would offer good alignment and sufficient clamping force without being too awkward to apply. To get to this stage, I veneered the front edges of the chipboard with 3/8 inch wide strips and applied wood dye to these pieces. I also flattered the varnish back on the panels and reapplied 2 further coats, including the additional veneer. That completes the external work, and the next stage is to glue the softwood battens inside the cabinet. To ensure that I place all the battens in the correct positions, I've laid them out over 1:1 scale drawings of the front and rear arrangements. I will glue in each batten individually using EvoStick non-drip contact adhesive. Should any parts of the veneer lift because they weren't glued down sufficiently, I'm going to insert stainless steel panel pins to guarantee a secure hold. Some care is needed to avoid splitting these softwood battens when inserting the panel pins and wood screws, so I've pre-drilled 2mm diameter pilot holes in the front cover battens at the screw positions. Reviewing the cabinet with all the softwood battens now in place, you can see that I have inserted 2 panel pins in all 4 rear cover battens. This was necessary because I found that the veneer lifted in one region and some of the softwood strips were not completely flat. I considered how best to cover the front baffle with the vintage Veneer covering material, and I decided that stapling around the edges was preferable to gluing. This is how this other baffle was attached. The advantage of staples is that they can be removed to reposition or retension the cover material without risking tearing it or leaving any residue. Fortunately, the glue holding this vintage material in place was well aged and had lost its integrity, so I was able to remove it from the original baffles quite easily. I did some test stapling in this chipboard offcut to check insertion and removal before proceeding. That's the front baffle covered now. I achieved this without needing a helping hand by clamping the panel to the table to keep the material tight against the front face. Firstly, I cut off some excess material, but I left enough to allow it to be pulled over each edge. I then worked along each edge, pulling the material tight with one hand and inserting a staple using the gun with the other. When all edges were stapled, I trimmed the excess material flush with the corner of the panel. That brings us at last to the final assembly of the loudspeakers and amplifier circuit board I assembled in part 2. The first task is to screw on the front baffle. I use stainless steel fasteners in all my build projects for longevity, and I try to match the type of screw with its vintage equivalent where possible. Next, I'm attaching the ELAC loudspeaker and TW4 16 tweeter using M4, that's metric 4mm socket cap screws, into the M4 stainless steel threaded inserts. Finally, I'm mounting the amplifier assembly using M4 socket cap screws into M4 stainless steel threaded inserts. I've opened out the 3.5mm diameter mounting holes in the circuit board to 5mm to allow for easy insertion and adjustment. I fashioned some anti-vibration mounts from silicone tubing. These will also reduce the risk of cracking the PCB when I tighten up the bolts. With the woofer and the tweeter and the amplifier PCB secured in position, you can see here I've now soldered up the connections, adding the woofer to tweeter crossover capacitor and link wire. It's a good idea to put some wadding inside the cabinet, and the purpose of this is to stop low-frequency standing waves being set up. The last two jobs were to just mount the battery wire terminal posts and screw on the 1/4-inch jack socket. And finally, I'll put the rear cover in place using some shims to keep it in the correct position, and then using some countersunk wood screws with cups to mount the heads, we'll screw the rear cover in place. All that remains is to attach the external battery connection lead, and that is the Brian May Deacy Amplifier replica complete. Okay, before we finish, let's take the opportunity to compare this replica side by side with the official KAT Deacy. Due to the amount of time that it's taken me to complete this video, I'm not going to do a demonstration here. So I'll leave you by saying thank you very much for watching this series, and please check out my future videos.